more numerical problem. This is again from inclined planes, and the topic is friction. So if you see this mass, this is given to be 75 kgs, and your new coordinate axis is this, right? So the first thing that comes to your mind is this force, which is gravity, and you're pulling up the body with 675 newtons upwards. You have to work on determining the motion of the object. Now, what type of motion does it exhibit, okay? And that's what you need to do. So let's focus on, so this is gravity, this is, we know the components by now. We're talking about G sine, this angle is known to you, G sine 30, and this particular component is also known to you. This is G cos 30, and then, obviously you have a normal reaction, when the two surfaces meet, and you have a normal reaction there. And then, since you're going upward, you're creating a relative motion between the layer of this box and the wedge. The relative motion gives rise to friction, which will be downward, given by mu n. So let's write the equation in the new coordinate system. So your new coordinate system, this is your, x-axis, and this is your new y-axis. And the way you put it is, let's assume the body goes up. Let's assume that, right? So 675 is the upward force, and let's find the downward force, which is 75. This is the mass, and G, which is, let's put it as 10, for simplicity, and this is 1/2. So what I've calculated is essentially, mg sine 30, which is trying to pull it down, and then I have to subtract the frictional force too. So you have 0.050 multiplied by the normal reaction. The body doesn't fly off like this, so the normal reaction and the force, this component of gravity, canceling each other. So normal reaction is G cos 30, and this is 675 minus 75 into 10 into 1/2 minus 0.05, okay, and multiplied by mass, which is 75, and G, which is 10, and this time around you take cos 30, which is root 3/2. And so what you get is 675 minus, this is 2 5s are, and this is 375 minus 5/100, into 75 multiplied by, so this is G cos 30, this is 10, and this is, just put in a larger, you can see it properly. So you have this as 5/100, so this is 10 upon 10, this is 5/2, and this is, I think we've already taken care of this, so we get 675 minus 375 minus, what you get is 75/2 into root 3, and this is 0.866, 1.732 divided by, you can divide it for there, and you could write this as one more value, which is 0.433, and you get 675 minus 375 minus 75, multiply by, so this is 0.433, so you could just take an approximate, and this is 675 minus 375. So 75 into 0.4 roughly is 300. So this is 300, and what you get is 675 minus 675 is equal to 0. I've done some approximation and I got the value as 0. So essentially what they're saying is that if you have to determine the motion, and with these approximations that I took, with G is equal to 9 instead of using 9.8, I used 10. The question is, whether the body is going up or down, this is what they're trying to ask you, okay? So if you get your, net force to be 0, this body is then, not moving, this is maybe balanced and it is moving with a constant velocity, and therefore the kinetic friction exists. So maybe the motion, the way you determine the motion of the object with these calculations, take it with a pinch of salt that I didn't take this as 9.8. I took an approximation here too, right? So if I do 75 into 0.433, my value is going to be a bit larger than 300. So if I get a value larger than 300 here, 675 minus 375 minus something, I'll get a negative number, which means deceleration, which means this body, instead of going up, will go down. So, take this calculation with a pinch of salt. If you go this and the body was moving, it's a case of balanced force, and we will say the body has constant velocity. But if you don't go with these approximations and you get a value here which is greater than 300, likely you're decelerating, which means the body is moving actually down. So that's a net resultant motion of the body, and it's not decelerating per se, but it is going down, and you will get a net force which is down the inclined plane, right? So that is the significance of negative. More to do with the sign convention. It has nothing to do with retardation. Okay, so just I think pretty straightforward in terms of you're trying to find a resultant force on the body, using the coordinate axis as this, and trying to decipher as to what could be the possible motion. Just be careful about these calculations of 9.8 or use of gravity 9.8 or 10 could make a slight difference in, if you get 0, it's constant velocity. If you get a negative sign, you're going down, and you could divide it by the mass then, and you will get the acceleration, which is downward. So I know this is not the precise calculation, but it'll give you a hang of how to approach it. You could probably take 10 as 9.8 and solve this question, and not even take this approximation, which I took as 0.4. I hope this helps you, and thank you very much again.